Okay, so here's the rotor pulled out. You can see the angle of the magnets in there. It's 35 degrees. And it goes around like this. Those are half-inch thick, 1-inch wide disc magnets, grade 52 neodymiums. And see that rectangular shaped, that's called a welding nut. It's got a really flat surface that goes against the rotor, so when you tighten up the nuts, it keeps it a nice 90-degree surface to the rotor. So I put this reinforcing material around it. This is a lot of round disc, wood discs I got at an art store, and then I epoxied between all of them. There's about, I don't know how many, at least a dozen of them. So it's kind of an epoxy wood rotor. And you see that little brass screw. That's when I rotate this how I want it to be. Like I want to try out 35 degrees, so then afterwards I put in that screw and lock it in place. Notice I reinforced the whole shaft with all these nuts here because I bent the shaft a few times when I used that really big pony motor. Just instant torque, it would just whip the thing. So now I'm using this rotoverter motor over here, which is only drawing like 30 to 40 milliamps, spinning this thing at 120 volts. And I can, when I want to check lens law, this is a really good tool to check lens law in generators, because when you load the generator and you cause that braking action, and this will really tell you. Very sensitive shafts. So I've got I don't know where they are, but I'm going to put this to north-south, north-south. I'm going to put 4 magnets in here. I'm going to change these to no angle at all, but flat, straight across for the beginning. Then I'm going to test this. So I got some numbers from all these tests I've done with these 2. And we'll see how that goes. I'm going to guess with 4 magnets in here, I can get it down to 1 amp. But that's still not good. I want to get it down to like 100 milliamps. So we'll see how it goes. How this could possibly work with an AC signal going into these 3-phase windings, just L2 and L3, and then the run cap phase, the rotoverter mode. How it could possibly work is that, and it did work, it just drew a lot. Also, I spun it for a long time with just spinning these magnets against here, and it didn't get hot. So it's not the magnets going past the laminates making it hot, it's just the thing's drawing way too much current. And I think it's fighting itself because, like, let's say this is north, this magnet and this magnet will cause a big north field, and then the other side of the magnets will cause a big south field. So you have, there's your AC that's going to latch to the AC. At least there's the north-south rotor that's going to latch to the AC coming in. But the changeover period is just the width of this magnet here. So it's like south, 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 and then small area, and then north, 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 small area, south, south, south. So it's hasn't been working very well. It worked, but just drew too much. So when I put in a north-south, let's say north-south, north-south, these two magnets are kind of going to combine, north against south, and they're going to shoot out a nice field like right here. And then on the opposite side, it's going to be doing the same field, north-south, but in between it should be a opposite. So in between these two should be an opposite field. So my hopes are when I put these 4 in, I'll have a strong field coming out here, opposite here, strong field here, opposite field here. So I'd have a north-south, north-south 4-pole rotor. And this is a 4-pole 3-phase AC motor too, so maybe it'll work. So this is what I'm going to try next. Notice how I reinforce the shaft with all these nuts, skateboard bearings here. So I'm going to put it back together and then do some tests. But now I'm going to have 4 magnets in here, north-south, north-south. Next step. Okay, thanks for watching.